Welcome again to another Baywa RE Solar Town Hall. It's great to be back with our solar community. And this week we're talking about codes and compliance. What are the pressing questions you have? We'll cover storage, creation of codes, working with your local AHJs. So we're really excited for a great group of guests today. We do hope all of you in Northern California are doing okay. It's a rough time with the fire season right now, so we're sending you all our best thoughts. A few quick announcements before we get started. We had an exciting announcement last week. We've launched a new partnership with Generac, and we'll be offering their storage products. If you want to learn more about Generac's Power Cell battery system, how to sell it, install it, ask any questions, you can come to that webinar. It's going to be on September 3rd. And Jessica is going to share all the links now in the chat or the Q&A. And then if you want to learn more about financing through Baywa, we know it can be a challenging time to start a new process in your company, but Rachel Shapira, the Director of Financing at Baywa, she's put a product together that's really easy to get started with financing with just one bill to pay. It's called the Split Pay Program, and it's in partnership with Sunlight Financial. So you can sign up for that webinar as well. And then this Friday, as always, after the town hall, we've got a mindfulness session, and that's at 8:30 a.m. Pacific. If you want to drop in and practice a little mindfulness, we'd love to have you. So first off, I have to admit that this topic is a little bit of a mystery for me, and I still feel like I'm out on my skis a bit. So forgive me if in this codes and compliance discussion I use the wrong terminology or numbers, but that's why we've asked our all-star guests to come on today. So with that, I'd like to start bringing them up. From Mayfield Renewables, we have Ryan Mayfield. And Ryan is launching a new live Q&A series, Ask Mayfield Anything, and there's another one tomorrow, I believe, and you could submit your code design questions and other technical questions. So welcome, Ryan. Great to have you for the first time on our Solar Town Hall.
Yeah, thanks for having me. Appreciate it.
And we also have Rebecca Wrench. She is now a solar engineer at Airbnb, and before that, she was at the wonderful solar training organization, SEI. She's joining us from, I believe, North Carolina, in the woods, somewhere, undisclosed location. Thank you for joining us today, Rebecca. We also have Matt Pace. Matt's a retired captain of the San Jose Fire Department. He was president of the Energy Response Solutions that focused on training fire and code officials, and now he's an advisor at the Pacific Northeast National Laboratory in their battery management materials division. So welcome, Matt. Thank you for coming on for the first time.
Thank you.
And on the contractor side of things, we have Vaughn Woodruff, the CEO of Insource Renewables. I'm not going to disclose his location. It's actually part of our trivia. Oh, he took it off. Okay. Well, if he brings it back up, we have a trivia question related to Vaughn. But thanks for joining us again, Vaughn. Great to see you.
Thanks for having us, Tom. I'll flip it around and get it set up for you.
All right, cool. So we should mention that Matt, Ryan, Vaughn, and Rebecca have all been long-term members of various code-making bodies, and they are the experts that are going to answer your questions today. But before we get to the first question, at the beginning, if you missed it, we have some trivia. And so the first question was, and we can test our guests' knowledge of Egyptology as well as codes, but who is the ancient Egyptian deity of the sun? And feel free to shout it out, guests, if anybody knows it, but it is Ra. Ra is the sun god of the ancient Egyptians and is depicted with the face of a falcon. So real quick, we're going to talk, this is the agenda today, we're going to talk broadly about the NEC, then we're going to talk about rapid shutdown, working with AHJs, products and manufacturers, storage, and who is writing the code and how to get involved. And then we'll wrap it up with some recommendations from our guests on how to streamline your install process as well. So I'd like to start off with the broad question. When it comes to the National Electric Code, the NEC, where is it helping solar contractors and where is it hurting them? And maybe, Rebecca, we'll kick it off with you and then we'll kick it around a bit. So yeah, Rebecca, why don't you kick us off?
Yeah, so that's a really good question. I think that clearly the intention of the NEC is to protect people and property. and it's a safety code. It's not a code that was designed for building low-cost systems necessarily or efficient systems necessarily. And so I think that there's always going to be a bit of a controversy between National Electrical Code standards and what might be the lowest cost installation. But I think that everyone who is involved in the code making process is very aware of that. And while code changes are always going to be focused on increasing safety, there's also, a lot of awareness that we don't want to necessarily always be increasing costs when we increase safety. And so I think that a lot of times when installers read the newly revised code and there are additions or amendments that they find upsetting, I think a lot of times that boils down to where the code is increasing cost. But I think that also it opens up a lot of room for innovation in terms of new products and new installation methods that can do both things at once, increase safety and decrease cost. And I do think that in the last few code cycles that we have seen some, simplification of Article 690 and Article 705, where I think we are working more closely with manufacturers and installation partners, trying to get those voices heard in the code making process so that we're not always just increasing cost.
Right. Anyone want to jump in there? Ryan, Matt, Vaughn? What's working and what's not working? How are the solar contractors being supported, and how are they being, challenged or potentially hurt?
I might also just add that often change is painful at first until you develop your systems and understand that it's not necessarily as disruptive as it might have originally looked. And I guess one example I would put up is that prior to a lot of the current best practices and codes and standards, those of you who've been around for a long time, modules were wired together with wire nuts and conduit between modules. All right. And then it evolved to multiple hundreds of zip ties on a residential system. So those are a couple examples where, MC4 style connectors and clips on modules have actually increased the speed of installation and decreased costs. So one perspective there.
Mm-hmm. Vaughn, did you want to jump in?
Sure. Yeah, and thanks for having me. Is kind of on the ground. I haven't been on both sides of this. So a lot of my code experience isn't in the PV world. It's in the solar water heating world, where I sat on the Uniform Solar Energy Code, worked with standards with IREC and IAPMO, and been able to see both sides, kind of the need, obviously, from a quality and safety, as Rebecca and Matthew have talked about. And then just kind of as it hits the ground, some of the impacts it has. Coming from that ancient solar water heating world, I remember doing a training in New York, and there was a SunPower training going on next door. And the folks who were attending were coming out kind of chuckling at the maintenance heavy technology that we were working on, which was solar water heating, which was perceived to be pretty maintenance heavy. And I would say that the code changes that have happened over the last few cycles, I think the inverter manufacturers have had a really hard time catching up and doing it with quality. We've seen a really big decrease. Some of the companies that we went to as the gold standard, we're out servicing those systems quite a bit. We work with a company that in Maine had a really bad reputation. They increased theirs slightly as everyone else's went down and switched our product selection as well. So it's definitely a challenge on both sides of that, like finding codes that are applicable, especially in solar water heating, where there's a lot of geographic consideration too that might be different. Looking at that in the PV world where things are a bit more uniform, I think that we've just seen, there are some challenges. It's important that the participation and the perspectives are incorporated into that. And I think that a lot, as Rebecca and Ryan and Matthew will go, there are a lot of pathways for that type of participation. Yeah.
And we'll talk more about the manufacturer side of things as well. Ryan, did you want to jump in there?
Yeah, just the one thing I was going to add is, PV, Article 690, we're in the special equipment section of the NEC, and we as an industry have, a lot of allowances. And so as the others have already pointed out, change is hard. And then the perception of changes being more costly is difficult. Rapid shutdown probably being one of the biggest pain points we have seen in the past few code cycles, just in terms of getting the adoption. But the other flip side of that is, we're doing things, Matthew made a great point. We're doing some things that electrical contractors otherwise don't do. You don't see 600 volt DC wiring in free air anywhere else. And so we do have, these allowances, if you will. And so I think it's important to realize that with PV being the evolving technology that it is, that we don't fit into that mold. And so applying code can be difficult, but we do get it on both sides, I would say.
Great. Well, you kind of gave me my transition there into rapid shutdown. Why don't we stick with you and talk about, what are the best practices? And these are all audience questions, by the way, and that have come in beforehand. And feel free, audience members, to throw your questions for our guests in the Q&A. And our guests can interact with you there as well and answer questions as we go. But yeah, Ryan, what are the best practices for rapid shutdown compliance when adding to existing PV systems that were installed without an RSS?
Yeah, and this one is actually somewhat of a near and dear to my heart question. This might have come from somebody in Oregon, because this is something that is being attempted to be addressed in the Oregon Electrical Specialty Code. So we follow the model. The model code is NEC in Oregon, and then we have a specialty code. And so what the best practice is, that's a difficult question for me to say, because if you're adding onto an existing system, the problem would be the thought would be that you're adding a system to the current code. You have something that might be 10 plus years old where there has no rapid shutdown. And the thought of a first responder walking up to a system, seeing that there is a rapid shutdown switch, but it only protects half the array, that they see it as, what they see as half the array, that becomes very difficult. And so, I would say signage, but it's really difficult to clearly indicate that. So one of the attempts here in Oregon is to actually require some level of rapid shutdown on existing systems, which I think it's a difficult thing to argue against. The hard part for me is the execution of it, given where our industry is going with module level rapid shutdown. We're not going to have, so if you're going to bring an old system up to date, then you're going to have to remove every single module, add equipment, so you're likely introducing more problems than you're going to potentially solve. And then there's also the option of doing some sort of rapid shutdown on the exterior output of the system. But to say that there is a quote unquote best practice, I think that's difficult. If there are options of adding some level of rapid shutdown to the output of the system, I think that's great. Just so that it's not, you don't have vastly different systems if you're adding onto it. Short of that, hopefully some real clear signage to get the first responders, and Matthew may have some input on signage as first responders go, because it's very, you don't want to create something that's a small book for them to read in order to know what's going on when they're on site.
Mm-hmm.
Yeah, I'll just say that one of the challenges with codes is not being too prescriptive. I think when it's performance-based, it works better because there's always an installation that's unique, and that trying to follow the letter of the code sometimes can result in miles of more conduit and disconnect some crazy location away from the array. And so that's not necessarily the goal. I think, if the industry and AHJs understand the intention, which is to try and provide accessible disconnect location, marking that is reasonable. Marking has become a real challenge. It's, when I teach firefighters, I would use pictures of installations that would have so many red labels on it. It's just overwhelming. And so ultimately, I think that we're getting to a place where there's more automation for the safety features. That's the goal. I think trying to train every firefighter is a completely unreasonable expectation, and that's always been my vision from a decade ago, is trying to put some of these safety features into the system design, into the code, so the fire service doesn't even need to have any training or need to read the labels. The execution of that's sometimes challenging, but I think that's the ultimate goal.
Mm-hmm. Yeah. Well, yeah, Vaughn, go ahead.
Can I jump in on that, Tom? Yeah. I think there are kind of two pieces to this, I guess. One is kind of what is the technical solution, but I think also there's what are the relationships and how do you go about doing this? I mean, we had this come up 2 weeks ago where, we had a non-rapid shutdown system on an old barn, and we talked to the fire chief first, right? Find out what are your concerns? Come to find out they had very little expertise at all with solar, which opened a door to create a relationship and help increase, right, their knowledge in that. And then talk to the state electrical inspector who is the HJ for that particular job. And theirs was just kind of a hard and fast, you got to do the letter of the law. So we just decided not even to put it on the roof just because it would create too much uncertainty, and talked with the customer about it. But I think those relationships are really critical, especially in markets where there's not a critical mass of expertise and experience, right? So Maine, we have so many small municipalities, many code inspectors, a lot of volunteer firefighters. And it's really important to have those conversations early and to check in, because those could be expensive from the contractor side. There could be some expensive assumptions in there. Should someone come in at the end and say, well, that's not gonna do me what I need it to do. There's not a cheap, again, to Ryan's point, as far as retrofitting old systems, there's not really inexpensive solutions to fix that problem.
Yeah. Great. Rebecca, why don't we bounce over to you? And I did mention that I was going to, have a trivia question where is Vaughn located? You might have heard that in his answer, but if anyone knows, just throw it inside the chat there. Where is Vaughn sitting right now based on his sign? Rebecca, alternate solutions for module level rapid shutdown. What are your thoughts?
Yeah, I mean, so obviously this has been a huge topic of conversation for the past 2 code cycles. With many interested parties. And I think that, Matt was possibly alluding to it when he said that, performance rather than a prescriptive path might be an easier approach here. And one of the things you'll start to hear more about is UL 3741, which is a new UL standard for PV hazard control, which is going to be, you'll see it in 690.12 as an option for rapid shutdown compliance inside the array boundary. And, while it's not, and I do think that UL 3741 opens up the window for more performance-based ways to comply. And so I think we're going to see systems that are listed UL 3741 that may look a little different than what we think of as the typical, module level shutdown, with, different approaches to safety, different approaches to even voltage levels. You're not going to have those precise, voltage level constraints for 3741 systems. And so I think we'll start to see a lot more of that in the next few years. And I don't know, Matt, if you have anything to add, if you've seen any movement on that front, but there's been a lot of work done on that standard in the past couple of years. And I think Matt and I are both on that standards technical page.
So let me just say that in my role with Pacific Northwest National Labs, I lead their energy storage safety codes and standards. So I've shifted from the PV world to the energy storage world. So I'm not on that STP anymore. But what I would like to say, since a lot of folks on this call probably don't know what 3741 is it is a product standard that, like Rebecca says, more performance-based. The idea behind it was to identify what the shock risk was for firefighters wearing PPE, and then based on that basic voltage, essentially, and current availability, have a system be below those levels. So it'll be very interesting to see what kind of products come out around that. I think there'll be many that will say, okay, well, we're comfortable using this type of module level control device. We've used it for years. We'll continue in that path. There'll be others that will seek to use, continue to use string inverters and then have a system that provides those lower levels of voltage and current. But that's essentially what 3741 is. And I think a lot of us are very interested to see what products come out to meet that.
Great. Matt, why don't we stay on you for a minute? There's a question. How is PV rapid shutdown addressed in codes and best practices when there is a battery energy storage system to keep the PV on during an outage?
Okay, so codes often lag technology. And so when rapid shutdown was first developed, we had to clearly delineate where the boundary is for a PV system versus an energy storage system. Because the energy storage system that might be there for backup does not know if a firefighter has shut off the main breaker or if the grid has dropped due to a tree down the line. And we wanted that backup system to continue to be able to operate. So the original discussion was a separate initiation of a shutdown of the battery was acceptable. So you'd have your rapid shutdown initiator for the PV system, but then if there was also an energy storage system, that would require an additional initiation. I think some of the trends that we're seeing from manufacturers, and it's a positive trend, is to try and incorporate a signal from that initiator to also address the battery. I think that that's a positive trend, but the codes don't require that. So for right now, the codes will require not only initiate for the PV system, but a disconnect for the energy storage system. And that disconnect would have to be outside. So for right now, that's what's required. But I think the technology is moving in a direction where it'll be a single initiator. Yeah, hopefully that helps.
Yeah, Rebecca, do you want to jump in?
Yeah, I hope that everybody on the call has taken a look at the figures that are at the very top of 690. 690.1 informational note. It's an informational note figure, which means that it's not enforceable, but they're super useful. And so basically, I think the really useful thing about those diagrams is that they call out the PV system disconnect in all kinds of different system topologies. And anything in 690 only applies, before the PV system disconnect. And one of the reasons we really wanted to include those diagrams in Article 690 is because of a lot of confusion about where rapid shutdown was meant to be enforced. And so this question comes up a lot about, does rapid shutdown apply to multi-mode inverter output circuits? Does it apply to the energy storage system? And if you take a look at those diagrams, I think it definitely helps clarify that rapid shutdown is really very specifically limited to PV system circuits, up to, depending on, A or B or what option you're following, but it's really, there's a constrained applicability to rapid shutdown. But like Matthew said, there are also requirements for readily accessible disconnects for energy storage, but that is a different category than rapid shutdown. But those are great diagrams. If you haven't scrutinized them, I really like those diagrams.
Mm-hmm. Great. Rebecca, well, let's move off of rapid shutdown and stay with you, though. But we got another audience question, and I believe you have some slides for this, which Jessica is going to queue up. But your opinions, interpretations on bonding PV AC disconnects for supply-side interconnections and whether an EGC is required. And just
so this is
Go ahead.
This is a super interesting topic that. So Matt and I are both on co-making panel 4, and we must have spent, I would say, almost a whole day talking about this in the second draft meeting. It's something that we know has caused an enormous amount of confusion among installers and inspectors all around the country because the rules were just not clearly defined. It was really hard to figure out what to do. Reading 230 and 250 and 690 in the electrical code, it was almost impossible to figure out what the co-compliant thing to do was. And so we spent a lot of time working on this in the 2020 code cycle. And unfortunately, what happened was that the language that the code panel agreed upon made it through all the way to the final second draft, and then was deleted basically at the very last minute through some, things like that happen in the code-making process. And so I wanted to, if we can share that language, and also Ryan has a great diagram that I think illustrates what the code-making panel decided upon. So it's one slide. Click down one slide. Sorry. So this is the language that was voted on and balloted by the code-making panel after a lot of conversation. And so the too long didn't read version of this is that you do not want a second bonding point in your PV system disconnect. that is what we decided. We decided it was safer to keep the grounded conductor and the grounding conductor separate until you get back to the service entrance. And so that's that highlighted last sentence there. No connection shall be made between the supply side binding jumper and the grounded conductor at the disconnecting means. So this is for supply side connections. This is a supply side PV source disconnect. And if you're not familiar with supply side binding jumpers, they look and feel and act a lot like equipment grounding conductors, but they are sized a little bit differently per 250-102. And so that my recommendation, if your inspector hasn't made their mind up about how you should do this, my recommendation would be to size and install a supply side binding jumper from your PV disconnect to the service entrance main bonding point. Brian's got a great diagram of this we can look at. Size it for 250-102 and don't bond in the PV system disconnect. So Ryan, I'll let you take over and talk through your diagram here. But
Sure.
The code panel really came to consensus on this, and after a lot of discussion, we think this is really the safest and best approach for this.
Yeah, and so this is a diagram my team has put together, and we use this when we're doing our code discussions as well. And something I like to say when I'm talking about this slide specifically, I say it only half jokingly is, and I think Rebecca, you were in the room when I give this example of sitting in a room with 10 people talking about this very topic. Everybody gives their opinion, and by the time it's gone full circle, you have 12 different opinions because undoubtedly somebody's changed their mind on what they think is the right answer here. And so I was really excited when I heard that NEC was going to basically finally give us some definitive answers or options, at least, on how to do this, and was slightly disappointed. And when the final version came out and it was cut, that language that Rebecca showed us was cut. And so this is what I've promoted and had people do. So to the point of to bond or not bond. So over there in the PV system disconnect, we're keeping the neutral and ground separate. And then in the main service panel is where that bond happens. So that's really the big gist of all of this. I was actually going to ask Rebecca the question that came up, because I always talk about how we got so close in the code making panel and into the 2020 code. Where's the best place to go find that draft language if we're talking with an inspector, so we can say, see, we were so close, but at the 11th hour it got pulled out. Does NFPA keep that on their website, or is there a way to access that?
Yeah, they definitely do. So you can go onto the NFPA website under NFPA 70. You'll find all of the actions that happened in the last code cycle. And if you look under the second draft ballot for Code Making Panel 4, you'll find that language, and you'll find the voting record, and you'll also find the one negative vote. You'll find the commentary on why there was one negative vote. So I think and there's also a lot of supporting commentary. So I think that's something useful. And Tom, I can share it with you if you want to make it accessible.
Sure, great. Thanks, Rebecca. Maybe we can touch on this question real quick before we move on. This is kind of in the grab bag category, but for Rebecca, let's stay on you. For 1200 amp services or greater, can the main service disconnect circuit breaker act as the PV disconnect instead of a fused blade disco? Rebecca, I think you're muted. You're laughing and talking, but we can't hear you.
Sorry. Yeah, I'm going to go out on a limb here and say no. I think there might be more to this question than it looks like. I think there might be something about rapid shutdown behind this question, but basically, if you look at 705.12a, it requires that each PV source, have a dedicated OCPD and disconnect, meaning that your system source disconnect can't be the main disconnect because you need a dedicated disconnect. It doesn't necessarily mean that you couldn't use the main disconnect as your rapid shutdown initiation device, but your PV source is going to require its own dedicated disconnect. So my answer would be no. And I would also just throw out there something that people often get hung up on with large services is not to forget that with a service that's greater than or equal to 1,000 amps, there's also going to be ground fault protection requirements, which can make it trickier to even have a load side connected PV system. It will be necessary to get manufacturers instructions that actually say that you can do a load side connected PV system is typically what happens. So I'd be curious to hear what Ryan or Vaughn think about this one, because my immediate reaction was like, I kind of think maybe this is actually asking about a rapid shutdown initiation device, but I'm going to leave it at no, just to make it simple.
Yeah.
I would agree to call it the PV system disconnect. I would agree with you there, Rebecca, and say no. Initiation device for rapid shutdown, sure. But then the other part of this, and I get hung up on, well, not hung up, but I say this a lot in classes and things. Looking at the definition of a PV system, that's in Article 100, and then the PV system disconnect gets attached to the PV system. So we're talking about two different systems, really. So if I'm understanding the question correct, I would be all on board with what Rebecca said.
Okay. And I realized I should have posted that question to everyone in advance, but it's there in the chat if you want to look at what we were talking about. But let's move on. Let's talk a little bit about products and manufacturers. We got a question about, in the past, we've seen code updates effectively eliminate manufacturers from participating in the market. Should we anticipate this happening as states adopt the 2020 NEC? Let's throw that out there. Anyone want to jump in on that one? Don't all speak at the same
So I'm scratching my head a little bit. I'm not familiar with where the code has eliminated manufacturer, and I'll take a stab that what the submitter might be meaning is that with rapid shutdown. Are they feeling that it's eliminating string inverters? Is that what's behind that question? And if that's the case, let me just say that it's not the intention of the code to choose winners and losers. It's totally driven by safety. And the industry is responsible for responding to market demands and complying with codes. So I think that's how I would address that one.
Mm-hmm. Vaughn, did you want to jump in there?
Yeah, I mean, I would assume the question would have to do with when rapid shutdown first came out and manufacturers struggled to get an OEM product out in the market at the times that things were adopted. So yeah, I'm not sure if that's the question. If it is, I mean, do you all folks see any other technology changes that might be maybe the question would better be, are there any dramatic shifts that are coming that manufacturers would have to run to catch up to be able to stay competitive in the market?
Yeah, there's another question kind of related. The 2020 NEC, does it require the development of new products in the market?
Again, let me just say that I think when rapid shutdown first came out, the products that were currently available were either microinverters or DC optimizers to meet that code. And I think that created a lot of tension. And it wasn't necessarily favoring any particular manufacturer, but since that language came out, there's a number of products that can provide that ability, whether or not they are product of choice for installers or have a track record of reliability. That's another issue, but there's not an absence of products in the market. I think one of the good examples there was arc fault detection. At the time that standard came out, there was not existing arc fault breakers that could provide that. And so that was a perfect example of there being a real bottleneck on products. But right now, I don't know that that's the case. And to Vaughn, what's coming down the line for manufacturers, I think is going to be in the energy storage field. So I don't want to jump off PV if we're still on that, but that's going to be an area manufacturers need to be very aware of.
Well, maybe let's stay on UMAT and talk a little bit about a quote that we've been sharing on LinkedIn from you. And you said, the solar industry can recognize hazards and address them ahead of regulations with safety technology and better design. You want innovation to lead the way. Can you talk more about that? And we'll get into a little bit more about, building the code and who can be involved in that process. But how is industry and innovation going to lead the way?
Well, So let me go to the two products that I mentioned earlier, microinverters and DC optimizers. They were first developed to address either a binning issue with module output or shading performance issues. But as a side function of that feature was the ability to isolate an electrical, to bring down the voltage when the devices are off. So there was a safety ability that was inherent in those devices. Now, not designed or listed for that. That came later. But I think that was one example of where there's some innovation that could help lead safety. I think another one in the energy storage field is where manufacturers are looking towards equipment design, chemistry design, system design to provide a higher level of fire safety into their batteries. Their early products and maybe products that don't have the engineering or development behind them might not perform as well in the UL 9540A tests. And that's kind of the threshold that we're at with energy storage, is just starting to rapidly deploy them in the residential market. And that's a very precarious place, I would say, for the industry. It's still very new. There's very few residential products, few that have gone through the 9540A, and that test is a large-scale fire test. That's part of the overall listing. And so I think that's an area where the industry is going to have to really step it up and be very innovative in ensuring that these products are very safe to be put inside dwellings, which the industry has fought for in the code, and it's in there. And it's talking about getting in over your skis. That might be one area.
Yeah, safety is a big concern. So let's just move into storage. Ryan, do you have any thoughts on this? Do you want to build off of what Matt said?
Yeah, I think it's with our industry in general. It's, as Matt was saying, it's we're innovating well before what the code can keep up with, and so trying to find that balance is important. But in a lot of ways, I mean, the code making panels can only do so much, and they're in there writing the 2023 code right now. It's due very, very soon, if not already. I mean, September is coming up quick, and so I mean, the code making panel is essentially 3 years behind the industry. And so what the changes we see just in energy storage alone, to kind of keep on that topic, it's important for us to not skirt the issue and to kind of shy away from it, but rather embrace it and try and make those changes in a positive way, so that the industry and the technology can be the leaders there, not waiting for the code to catch up.
Yeah. Matt, back to you on another question from the audience. What will be the impact of NFPA 855 on Resi and C&I solar and storage designing, pricing, and installation?
So 855 is the standard for stationary energy storage, and NFPA, that particular standard will become adopted and enforceable in two ways. One, it's either a state that adopts the NFPA codes, and that's their building and fire code. The other one is it also informs the International Fire Code, which is the adopted code in the majority of the U.S. So there's an attempt at harmonizing the language between the two to help the industry have some consistency. And the first edition was published this year, 2020, and we're currently working on the 2023 cycle right now. And I think it's a very significant document in that it is trying to address some of the safety issues with certain technologies. The challenges are that it sometimes is overreaching for other technologies. So we're really trying to make sure that the risks are addressed for specific technologies without being too prescriptive. And I would say that the release of the 3 public reports as a result of the APS incident, April 19, point towards some commonality gaps that really need to be addressed in fire safety, in both suppression design, gas management, if there were thermal runaway, and then also education, training of responders, decommissioning plans. So it's a very significant document, and it typically addresses larger systems. The fire code has many more requirements for larger systems than the residential requirements have. And I think that the potentially gray areas that you can have some potentially large residential systems up to 80 kilowatt hours. And that's a significant amount of energy. And it would not need to follow the fire code requirements. So that's why I really caution the residential industry to, I guess my advice is more to the manufacturers, because you guys just want to install listed products, and you should. But the manufacturers really need to make sure these products are the safest possible, because they're going in our homes.
Mm-hmm. Does anyone want to jump in before I move us off of storage and into working with AHJs? Any other thoughts on storage? Yeah. Well, maybe let's talk a little bit about moving away from products and storage, and how to work effectively with inspectors and AHJs. Everyone has their own horror stories, but Ryan, why don't we kick it off with you? What are some of the best practices about working efficiently and collaboratively with these groups?
So what I've found, so I've done a lot of training over the years, and so I've had a lot of code officials in my courses, as Rebecca and Matt both have, and I know Vaughn's done training as well. So the big thing that I keep trying to, when I talk with installers specifically, is the inspectors, they have honestly an overwhelming position. They have to know everything about all systems, and they have to be able to go in and inspect something in 15 minutes and know the codes back and forth. And now we're getting, combination electrical plumbing inspectors in some jurisdictions. We have inspectors that are third parties. So they can't even get on a roof, for example. And so they're doing PV inspections from the ground, which for good or for bad, that's happening. But one of the things that I really encourage people to do, and I try and walk this as well, in our business, we do a lot of design work, and so we get a lot of interactions with contractors when their inspectors have questions. A lot of times the inspectors will ask for a change on the system, and they could be just dead wrong, honestly. And I think for a lot of people, the reaction is, okay, well, I'm just going to do it. It's a small change. I'm just going to do it, get my green card, and I'm just, I can close this job out. I really encourage people not to take that route, because yes, it is probably the easiest, especially if it's a really small change. But at this, taking the time, working with the inspector, talking to them, taking the role of being an educator in this case, to show them, how the interpretation or how the code doesn't apply, is just going to help that inspector down the road. They're just, they won't do that in the future, for one, but then it's just going to make them, I think, a better inspector, make them more aware. So that's one of my biggest things, is when an inspector says, here's what it is, don't just take it as gospel. And the other part of it that I get, and I'm amazed how much I get this, is an inspector, well, you need to install a 6 ground. And, well, why do I need to install a number 6 ground? And they just say, just because. And so pushing them a little bit harder of citing the code, why, okay, I hear you, but why, what's your justification? And so I think a lot of installers are reluctant to do that, just because they have to work with those inspectors a lot, and they don't want to honestly make them mad. They don't want to, start off with on a bad foot. So, or, sour that relationship. So taking it in a positive manner, not being aggressive about it, but at the same time, trying to be educational about it.
Mm-hmm. Yeah, Vaughn, you have lots of experience with this. What are your thoughts?
Yeah, I mean, I like to just kind of step back and look at the human dynamics a little bit. just in that there's like a natural tension and conflict that often exists between contractors and code officers, right? You got code officers who are trying to make sure that they're protecting the health and safety of their charge. You've got contractors that are trying to, function in a market. And what we found to be really helpful, I started in the industry out in Montana where towns are few and far between. So we might only work in a few jurisdictions. And in that case, it's a lot easier to form those relationships and really be proactive. It's always nice to have a conversation on code when there isn't a project in front of a code official, just so you can talk about generalities. We'll call during the sales process, right? Like we may have a project where, there's something that's out of the ordinary. And asking permission versus begging forgiveness is something that code officials like a lot. And I think that it's inherently in your best interest to do it. And I think just generally, especially in markets that aren't mature, where you don't have general code official knowledge across the board, if you can become a contractor that those code officials lean on for interpretation, that's the gauge of how well you form those relationships.
Yeah, Rebecca, jump in there.
Yeah, I think that it's important not to underestimate how complex some of the requirements in 690 and 705 have gotten over the years. In particular, I'm thinking about the 705.12b and the requirements for load side connections and bus bars and feeders. We keep adding more and more and more options and rules and constraints. And I'm also thinking about things like 690.9 overcurrent protection, which if you looked at it recently got a lot longer in the 2020 code, but it didn't necessarily get a lot clearer. And so I think you can get pretty bogged down in some of those rules and requirements, particularly if you're an inspector who doesn't spend a lot of time on solar or maybe has spent no time inspecting PV systems. And so I think like at the end of the day, what you really need to think about is, is this safe? Like, is what I'm doing here, what I'm trying to do, is it safe? Do I feel like I've met the safety requirements that are really at the core of what we're trying to do in 690 and 705? And if you're having an argument with your inspector about, whether your wire size is right or the overcurrent protection or your interconnection point, I think sometimes you just have to take a step back and think like, is this a safe installation? And, if it is or if it's not, those are really, you got to get to the bottom of like what you're doing and why, because there's a lot of, I wouldn't call them loopholes, but there's a lot of different ways to apply the requirements in 690 and 705. And, I think that you probably could, if you tried really hard, end up with an installation that wasn't safe, depending on, what puzzle or path you follow through those requirements. And so I think at the end of the day, just think, what I'm doing here, is it safe? Does it meet the requirements of, the safety of the building and the safety of the inhabitants of the building?
Mm-hmm. Great. Thanks all for your thoughts there. I'd like to look ahead a little bit as we start to wrap up the show. What does the next 2 years look like? Ryan, why don't we start with you here? How are you seeing things play out? Are we continuing to get more and more prescriptive, in particular for solar specific electric codes, or have we passed the tipping point to where things are more integrated and aligned with the electric code and solar requirements? I get. Are we on the right track, for codes to support and not hinder the industry?
That's an interesting question. I would, in general, I feel like we're going to continue. This is going to continue to evolve. I mean, as we're seeing NEC specifically evolve on 690, specifically 705, as Rebecca and Matt have already said. We have brand new codes, we have brand new sections, there's a lot that's still honestly being developed. And so, are we at that prescriptive point? I kind of feel like no, just because the industry is so rapidly changing, and it's just really hard for the codes to do that. I mean, the electrical industry, we've been doing electrical installations for over 100 years now, right? So it's the code in those, our standard electrical systems, I would say, even those are changing pretty rapidly. At this point, we have some technologies that are crazy to me, and it's kind of hard for the code to keep up. So, I don't know, will we ever get there? I have a hard time seeing it, but, that would be awesome if we did. But for the time being, for the next, 2 years, definitely, I would say no. And then, the codes are, we're just writing new codes and we're getting new stuff coming in. So I expect it to be helping the PV industry, but there's definitely going to be, tripping up along the way for a while yet.
Mm-hmm. Anyone want to jump in on that? I have a question for Rebecca about 2023 NEC, but any other thoughts on, this balance of requirements in the electric code and what the next couple of years look like? Well, maybe I'll just, Rebecca, what's in store for 2023 NEC, 2026 CEC?
Yeah, so as I think Ryan mentioned, proposals are due for the 2023 NEC in about 2.5 weeks, which is not great, honestly, because we haven't gotten a lot of feedback from the field on the 2020 NEC, and so it's very hard to have all of our proposals written and ready in 2.5 weeks. And so I think people do the best they can, and when I say, people, I really want to encourage everybody on the call to get involved. If you have an issue with something that's in the code, the way that it's changed is through a public process of public inputs. So the public inputs are due September 10th. Like anybody on this call, any of you can put in a public input, and I would highly recommend that you do, because one of the things that happens, I think people are scared a little bit of this process because you think like your input or your proposal has to be perfect, and it definitely does not have to be perfect. What happens is when you put in a public input, it really opens up the topic or the section so that the code-making panel can discuss it. And the stronger a substantiation you have for making a change, the more likely that the code-making panel is going to put some effort into working on that language, even if your proposal isn't perfect, which of course none of them are, when they're initially made. And so if you've got a problem that you're always running into in the field, or something that just hangs you up every time, please think about putting in a public input or send it to me. I can help you out with the process. But it's a very public process. Go to the NFPA website. It's really easy to get involved. So.
Well, I want to add something to what Rebecca just said that's really important people understand. If you don't submit something, the committee cannot create it without there being a public input. And even if it's not perfect for the first draft, it could be adjusted. But if it's not in there, then you can't introduce new language at the second draft. So it's way better to get something that's written poorly in at the first draft. So don't worry about how it looks, just submit something and the committee will be able to work with it. And again, if you can get somebody to they reach out to like Rebecca that understands what you're trying to do, then they can help guide you through the rest of the process. But that's a really important part.
Yeah. Thanks, Matt. Rebecca, just to go back to you real quick. So, I'm overwhelmed when I look at a number with a dot and other numbers and then get involved. I'm like, how do I get involved? What does it actually look like? Do you show up somewhere? Do you chat with other people? How large are these bodies? Can you just describe what it looks like to participate in making the code?
Yeah, so SEIA, the Solar Energy Industries Association, has done a really good job of supporting a group called the PV Industry Forum, which is totally open to anybody who cares enough about the code to come and join. And so for the past, I'd say 4 months, the PV Industry Forum has had task groups. So if you're really interested in grounding and bonding, or you're interested in rapid shutdown, they've had task groups working on public inputs. So as a consensus group, getting together once a week and saying, okay, we want to rewrite this or rewrite that, coming to consensus on decision making. And that's a really easy way to get involved as a sort of newbie to the process, because you'll be sort of guided through how to approach this. So that's wrapping up, but there's still 3 weeks left. So you can get in touch with Evelyn Butler at SEIA if you want to get involved. That I would say is the easiest path into it. You can also just go straight to the NFPA 70 webpage, and Next Edition is a link there. You click on Next Edition and it'll take you right to submit a public input. And it's actually, it's a program called TerraView. It's actually like fairly intuitive, I would say. And it'll sort of guide you through how to submit a change. But I would say the best way to get involved for the next code cycle is through the PV Industry Forum. It's probably the easiest way. That's, I think, 4 code cycles ago is when I first got involved through the PV Industry Forum.
Okay. Awesome. Well, I want to start to wrap up here. There was a question that came in the Q&A, so if any of our guests have the ability to answer that question, that would be great. But for our final question, I'd like to ask each of our guests for their top 3 suggestions for solar contractors, kind of wrapping up what we talked about today, to achieve the most seamless approval process from utilities and AHJs. So how to make that process as smooth as possible for our solar contractor audience. But before I kick that off with Rebecca, I'd like to thank our guests. We have Rebecca Wren, solar engineer at Airbnb. Thank you for coming today. Ryan Mayfield from Mayfield Renewables. Thanks for joining us. Matt, great to meet you and have you on the show for the first time. He's a former fire chief and now advisor at Pacific Northeast National Laboratory. And Vaughn Woodruff, thank you as always, CEO of Insource Renewables. And the trivia question was, where is Vaughn located? Based on the sign here. Trick question, Vaughn is in Maine. And then Jessica's going to post the other the other different trivia questions in the chat. So check for those answers. So yeah, Rebecca, let's kick it over to you. What are your top 3 suggestions on seamless approval processes for codes, compliance, AHJs, all of it with solar contractors?
Yeah. Well, first, thanks, Tom, for inviting me. I've enjoyed being here with y'all.
Mm-hmm.
Top 3. Let's see. So I would say, I think probably education. Can I just make that the whole top 3? Just making sure that, you're educated about codes and standards, that your crew is educated, and also that your local AHJs are educated. So, as Vaughn said, reach out ahead of time, make sure that you're not jumping to conclusions, and be patient with your local jurisdictions, because a lot of them don't have a lot of funding. They have a lot on their plates. There's a lot going on. Solar is not always at the top of their priority list. So, help them out with education where you can.
Yeah. And if everyone's going to say kind of the same thing, feel free to jump in with your top suggestion for solar contractors, in any of the kind of topic areas we covered. Ryan, why don't we hop over to you?
Sure, I'll just pile on that one just a little bit, just a yes on all that. One of the things I like to point out is, as solar contractors, you are going to know going into the job if there's something a little bit different, more difficult, supply side connection, for example, or adding to service disconnects, things like that. Talk to the AHJ ahead of time. And I think a big part of that is when you're asking the question, you can also be somewhat being in the educator role and leading that discussion. So you're not being reactive, not suggesting that you do anything to do something wrong by any means, but rather you are able to kind of help the inspectors see and interpret the codes in a lot of ways that we are as well.
Great. Yeah, Matt, final suggestion, thought?
I would tag on to what Ryan had said earlier, that if you're encountering an AHJ that's incorrectly interpreting the code, your margin on your jobs is very tight. You don't necessarily have the time. But what's really important is bringing that problem to the attention of maybe your local chapter, because it's important that they understand where the gaps are in education, and it can be addressed, not putting you on the spot at a different level. And that's been really effective. I did a lot of that when I was a private consultant all across the country, and it was pretty effective. But once the heels are kind of dug in over a project, it's difficult to move forward effectively.
It's a great idea. I never really thought about kind of getting an intermediary involved. That's a great idea.
We're all learning. Vaughn, final thought?
Totally. I think humility, while not necessarily valued in some realms in the world these days, is a really important one here when dealing with AHJs, and that helps to be a good learner, so that you can make sure if you make mistakes, code can be hard to interpret. Be ready to make mistakes and learn from them. It also goes a long way with the AHJs. I also think offering, you can get the answer to the question you want based on what you ask for a question. And so rather than, if there's something that's questionable and you're in a jurisdiction where it may be this way or that way, make sure you're well educated, but then offer solutions. Offer a solution that then can be the straw man or straw woman to put down and go at it with. And I think just generally, working in a territory, is to make those relationships be visible. Some of this stuff, it's going to be dictated coming down, but states and municipalities go through code adoption processes themselves. And so being vocal in those when you see something that may not be specifically, here in Maine, off-grid, for instance, we're increasing risk with some of the adopted principles, and it may just say, this is something here in our state that we really need to pay attention to so that we're actually dealing with the health and safety issues that we want to. So
awesome. Well, that's all we have the time for today. Make sure to check the links in the chat for our financing webinar, for our mindfulness session this Friday. Come out and chill out with us on Friday. It's a really nice, relaxing time. And our Generac webinar on September 3. Thank you to all of our guests. It's been enlightening for me. I'm slowly inching towards a little bit of knowledge in this topic area. So I appreciate it, and great seeing you all. Thanks for everyone for attending and joining our solar community. And yeah, we will see you next time. Bye.